Thanks for the warm welcome. And just on the first note, I got a 4-hour sleep last night, so I might stutter a bit. I'm sorry for that in the right now. Okay, so do's and don'ts of the task queue. First, who am I? I'm a Python engineer at Kiwi.com. We are doing basically airline ticketing and virtual interlining, if you haven't heard from us. And I'm specifically in the finance tech tribe, basically meaning that I'm the one who takes the money from your account. And you can blame me for it, if it's too much, or multiple times actually. Okay, the outline of the talk. First we will define what the task queues are, and then I will tell you a short story. Then we will show some examples versus reality stuff, and final setup from the story, and how we do it in the Kiwi.com, specifically the finance tribe, and some lessons learned, and if time allows us, we will do some Q&A. So, task queues. Is anyone confident enough to define what a task queue is? Never mind. I struggle as well, because I was trying to find some simple definition, but I couldn't, so I took Wikipedia and just smashed it together. So it's a parallel execution of discrete tasks without blocking. And this is not just for like high-level development with Celery, RQ, RabbitMQ, and other task queues managers or systems, but this also goes down to the CPU, scheduling, and hardware altogether. We have 4 major parts of a task queue. We have the queue itself, we have the task, that is the unit of work that we want to have done. We have the producer of the task, basically the one who creates the task and sends it to the queue. And we have the consumer who takes it up from the queue and makes something happen and satisfies the conditions. What a task queue is, we now know, but for what it is actually. In our, let's say, high-level programming, web development, business logic, and stuff, we usually use it for decoupling long-running tasks from a synchronous call. So, this is better, right? Once again, decouple long-running tasks from a synchronous call. This basically means that we can have a task that takes like a minute or even half an hour, and we don't want to block the HTTP API, for example. So we will just decouple it, throw it to the worker, and wait for the result with a callback or something. We can also do a task periodically. We don't have to use the low-level cron tab on our Linux systems, but we can have something more sophisticated, something more manageable, more monitorable. And we can actually know what is happening with it. This is very hard with a cron tab, actually. Break down software to more isolated pieces. Usually we do microservice architectures in Kiwi, but sometimes a microservice is way too big and Lambda is too small for us. And we want to integrate with another big part of the system, so a task is just the right size sometimes. Minimize wait time, latency, and or response time. This comes together with the first point to decouple long-running tasks. And it can really increase throughput of the system and the responsibility of the API. For example, when the API is user-facing, you need as fast responses as you can. Okay, story time. We have in Finance Tribe, we have a beautiful accounting service called Fantozzi. Maybe you have heard of the series of the movies with this unfortunate accountant from Italy, and if you haven't seen any of these movies, just watch some of them. It's really great. And we named the service after the unfortunate accountant because what it does is just accounting. Mainly right now printing PDFs in large volume. Let's say tens of thousands of PDFs every day. I believe that in the back you can't see the schema. Don't worry, it doesn't matter. It's just there to show like the initial redesign of the whole Fantozzi app. to be more modular, to use queues, specifically to use RQ framework, and to use some magic cloud thingies in one end, then use a database, some service webhooks, and comes with the super hot topic of JSON web tokens, authentication. So this was all bad, basically. This is all wrong. And you know why? Because during the development, we heard or said a couple of very dangerous sentences. The first one was, new is always better. It's not. Sometimes when you have a group of a couple of tens or even hundreds of developers, and there are some best practices in the whole company or in the topic itself of task queues or HTTP APIs or anything, it's always best to think twice if your new approach is really better than the battle proven by other developers. Think outside the box, right? Everyone tells you that you should always think outside the box. Like, we can do it differently. Yeah, no, don't. Sometimes just don't. I know everything I need, right? I read some docs, I read the introduction to Celery, I read introduction to Redis, and I read introduction to, let's say, Redis queues or some workers, AWS, and so I know everything, right? I just don't need anything else. I'm the smartest person ever in this company, right? I don't need to ask anyone. And of course, the best one, I can do it better than the other guy before me. No, you sometimes can't. Especially when you use the 4 other sentences before. So, before we reach the examples and reality, what happened? We were developing Fantasy, like the Fantasy 2.0, for something like 3 weeks in 2 developers. So basically 6 weeks of time spent on an app. And then we tried to deploy it, and then suddenly, oops, it doesn't scale, it doesn't work properly, it's hard to set up, it's hard to maintain. Why did we do it, actually? We just wasted 6 weeks of developer time for nothing. Because we were thinking outside the box. We thought that we knew better, because we didn't want to use the battle-proven Celery in our company, where we have best practices, we have even our own small frameworks that cooperate with Celery. We have some scaffolding for Celery, but we wanted to try something different. We wanted to try RQ, so we did, and we wasted 6 weeks of time. And 6 weeks of time in development time is a lot. And why it happened? Because we opened Celery docs. See, like a 6 line, 5 line introduction to Celery, how to start it, and you're good to go. Same goes for Redis. That's even longer, and it's supposed to be simpler than Celery, but still the example was longer. Yeah, well, it's all nice and easy. Like RQ is lightweight. We don't do some hyper stuff with Celery anyway. So we used Redis and went by the examples, but we didn't reach deployment step until we went to deploy actually something, and that was wrong. Because in the end, we found out, okay, we want some repetition in RQ. Well, Celery has it built in, but RQ no, it's lightweight. So we needed to build it ourselves. Yeah, well, don't. This is just a speck of what we needed to do to make some repetitive tasks. Like, again, there's some enqueuing, dequeuing, parameter passing. It's just wrong. Just don't try to read it, it's ugly. And surprise, surprise, in Celery, Petr is included, 5 lines of configuration, even with some time limits. You're good to go. Just, nothing super easy to maintain, super easy to understand. And just one note, when we are integrating Celery, you would be thinking that it's really easy, but it ended up with 18 file changes over a repository that was 25 files large, and 250 changes in total, with a project which was around 1,500 lines. So quite a major change for such a small project. So we have the final setup for Fantozzi, because when we realized that RQ is not the way to go, we took a step back. We took the scaffolding for Celery that we have available, and developed the Celery version in 2 days, in one developer time, because there was something broken and I needed to do something else. You know, finance, you're losing money. So final setup. Back to the topic. Sorry. We have Python, of course, and we have Postgres. That's the basic of basics. On top of Python, we have Flask and Connexion. Connexion is even on top of Flask. Just a quick note, who knows what a connection is? Okay, good. So 2, 3, 5 people at most. Okay, so I will mention it in the end, just a bit, because it's a super duper thingy. And of course, we have Celery, we have Redis on AWS managed, so we have reliable queuing system, multiple deploy targets in Rancher. Now it's outdated a bit. And we have Logs.io and Datadog for monitoring, Sentry when something goes bad, and PagerDuty when something goes really bad, and you need to be waken up at 3 AM in the morning when you're still hangover from the night. And how we do it in the queuing column, let's try all together. Surprise, surprise, it's the same. It's a battle-proven setup. It was used before, so we use the same as well for Fantozzi. With Python, finally we have the end of life for Python 2, so all new projects are 3.6 plus, or at least. And we already migrated everything from 2.7 to 3.6. And that means like a work of more than 400 developers. So it was kind of fun. And we are breaking monolith to microservice architecture, or let's say multiple monolithic microservice architecture. There's a combination of everything, depending on the team and on how they decide to do it. With Flask or IO HTTP, that's our go-to frameworks that we use. We have boilerplates, we have scaffolding for them, and it's really easy to set up for us. And just by the way, all these like small helper tools, small packages are available on GitHub. It's in our KiwiCom account, and you can find it there. It's open sourced, everything. And so for a complete HTTP REST API with documentation, with self-generating documentation, with schema validation, with authorization, with everything, it's just these 15 lines, and with database connection. That's it, nothing else. So it's super easy. With Connexion, okay, it's working again. With Connexion, we have Open API free. You know it maybe before it was Swagger, but right now it was changed to Open API Initiative, and it continued the numbering, so it's Open API free. It can define the schema of a REST API quite easily, and Connexion validates on top of the schema and generates the Swagger docs. Basically, it's a fancy page with all the schemas and data models on it. We are using token-based authentication, and if needed, also authorization. And of course, we are using Celery, where we follow the best practices, which I will present in a minute or so. With Redis on AWS, it's simple, it's reliable, it's cheap, it's easy to deploy. If we need something like really properly managed, we will use AMQP with RabbitMQ, and you're good to go. It's even more native to Celery than Redis. With deploying, we are deploying always multiple targets, counting in HTTP API, workers, beat, and some other services that needs to be generated, for example, for another documentation service. Because sometimes we're using Redocly. If you know, just try to look it up. It's super nice documentation. It's also generated. You don't have to write anything except the schema. We're good to go again. We are deploying internally from GitLab CI. We are deploying to Rancher, and now we also migrated to Kubernetes and to GCP, Google Cloud. With that, it's a bit more difficult with GCP because of Kubernetes, but with Rancher, what you need to have it deployed is just these couple of lines, and you're good for production and workers. That's perfect. Blocks.io and Datadog, we have it for extensive logging and monitoring, because when something goes wrong, you need to know. And with Datadog, it's connected to Celery, which can be triggered when some monitors in Datadog are triggered. And sometimes we just report to Slack and ignore the alerts, you know. That's usual. We just tick the box, yeah, we saw it, we know about it, and we forget about it in an hour. Then we have PagerDuty. Sorry, I'm sorry. I said something terribly wrong. We use Sentry for stack recording and PagerDuty for alerting. I'm sorry, I mixed it. Okay, lessons learned. Now we're to the bottom of the whole problem. Use Redis or AMQP, never a database for a broker. You may ask why. Because database, you have it already in place, it's there, it's working, it's easy to use, you can easily monitor the database by the number of lines in a certain table, and that counts you how many jobs are actually there in the queue, but don't do that. You can do this only and only on your own machine when you're testing it. Because your app grows larger, there are more tasks to do, there are more queues to manage, and then suddenly your startup hits the boom, everyone connects to it, everyone wants an account, everyone wants an invoice and everything, and suddenly your database is under attack by Celery, by insider. Because it will open like 500 connections for each of the task submission, and then you have the beat and you have the worker that is always asking, hey, are there any new jobs for me to do, for more tasks? And then suddenly you are DDoSed by your own service on the database. So you basically shot yourself in the back without you knowing it. But Redis or MQP broker, specifically, for example, RabbitMQ, are designed for these amounts of data or requests. So always use Redis or MQP. It's really super easy to set up. For AMQP, it's native for Celery. If you want Redis, just install another extended package for Celery and just specify the broker URL, and you're happy. And you won't get headaches in the night being waken up by PagerDuty. Pass simple objects to the task. This mainly connects to the database objects, database models. For example, if you're using SQL Alchemy, and you pass the whole object, like the created object that you submitted to the database, the object can go stale. It can be updated in the database by another worker, by another task, and suddenly your data model and the object is outdated, and when you try to commit it, you will have an error. And you will never find out why, because it's basically a race condition. And those are super hard to debug in a parallel system. So good luck with it. Always pass simple objects. For example, for database rows, just pass the ID, just pass the primary key and query it again. It's faster actually as well, because you will just put the bunch of binary data to Redis to actually serialize and deserialize the object, and that can also lead to errors. So pass simple objects. It's best to pass just strings, ints, floats, maybe decimals. That's fine. Do not wait for tasks inside tasks. This is connected with the next advice as well. But if you don't set up time limits on a task, this can lead to an infinite loop inside tasks. Like it will wait for each other. It will lead to deadlock. It will lock up the whole database, for example. It can really kill everything, and you won't even know it because it will just stop working. And if you don't have proper monitoring, you will never know. Set retry limit. If you have repetitive tasks, like when you tried five or six times the task, always tell Celery how many times you can try, and then just give up, throw error, and log it, or change parameters, reports to someone who knows what to do with that, just set retry limit. It's super easy, just max retries, dictionary, and you're good to go. Use auto retry for. This is a really nifty feature for Celery, and where you specify an exception class, and it will be called by Celery and repeated only based on the class itself. So you can specify your own errors, raise it depending on your own, or you can just do network error because you know you're communicating with HTTP API which is not reliable. So you can just retry for that, or for unauthorized, or for some 500s. That's it. And again, retry quars, otherwise it can DDoS the other service again. So we will just pile it up. Hey, something more. Retry backoff and retry jitter. With retry backoff, this will slowly increase the times between each tries. So when you're trying the endpoint, for example, when you're communicating with another service, it will wait with the next call a second longer, then 2 seconds, then 4, then 8, and so on and so on and so on, until you hit the retry limit. With retry jitter, this is a really important thing, because when you have a task that is, for example, scheduled to run every 5 minutes, use the jitter, because it will create like the set of tasks that will hit the API in the same moment. With jitter, it will add a bit of time for each repetition, so it will be distributed across time for that repetition. Set hard and soft time limits. This is when the task is stuck. With the soft time limit, it will ask nicely, hey, you need to end. So finish what you need to do and die. The time limit, it will just kill the task in the middle of everything. And it's really hard to pick up from that. So always set it up accordingly to have time to finish, actually, the soft time limit. Because it will tell nicely to the task, hey, you should finish. Use bind for an extra oomph in your task. Basically, it's a self-decorator. That's it. It will give you a reference to the task itself, and you can handle the task yourself. You don't have to rely on Celery only. So, for example, if something goes wrong with the HTTP request, you can log it. You can erase some error, and you can, for example, put some statistics to the Datadog. So you know when some API is not reliable, for example, and then you can again retry it, and this time, for example, you know that this specific API should wait 5 seconds longer. So you can give it some more time. You can disable the jitter because you know that it's just a single thing. Or you can increase the max retries, you can decrease the max retries. You can log again, for example. Or you can act upon it and record it to the database and keep it for later. Use separate queues for demanding tasks. Simply set priorities to your tasks. Because, for example, in Fantozzi, generating a PDF is kind of hard job for the CPU. So, like a single A4 invoice can take on a slow machine in Rancher, or on a small machine slow, it can take like a second or two if you don't beef up the hardware for it. Because it's CPU heavy, it can't use properly graphics on it because it's complicated with Alpine, for example, with Linux Alpine. So you specify a specific queue for it, because then you have other tasks that, for example, just upload it to the S3 or just record it to the database that it was done. Well, these really simple, fast tasks can actually starve out the long-running task, because it will always use the time for the fast tasks, and the PDF will be waiting infinitely to get in the line. So it will starve out, and it will be sad, and it will go away because it will be bored. So use specific tasks, use specific workers for it, And when you have the specific workers, you can beef up only just that machine that these workers are running on. So you don't have to pay gazillions of pounds to AWS or GCP for that one machine, specific machine that you're using to 100%, and others are just playing around with 5% CPU usage. You know, it will save you money as well. Prefer idempotency and atomicity. My brain is lazy, so I took the definitions from Wikipedia. And simply said, idempotence is a thing that when you hit, in our terms, when you hit an API twice, it will always produce the same result. It won't pay twice the same amount, or it won't withdraw twice the same amount from a credit card. It will just withdraw it once and correctly. And with atomicity, when you do something in your system, atomicity basically means that it appears to the system in an instant. Sorry. So it just occurs right now, and nothing else happens anywhere. A sum up of lessons learned. Use Redis or MQP, never a database. Pass simple objects to the task. Don't wait for tasks inside tasks. It will run it infinitely. Set retry limit, so it doesn't run infinitely. Use auto retry to smartly retry for exceptions. Use retry backoff and use retry jitter, so you will ease up other systems. Set hard and soft time limits for the tasks, so they can be killed gracefully and then violently. Use bind for a bit of extra oomph in the tasks, so you can lock, you can react, you can raise other errors. Use separate queues for demanding tasks, so the demanding tasks don't starve out. And prefer idempotency and atomicity in your tasks. It always helps. Things to consider when you're creating such an app. With Celery, there is one big niggle, and that is that the workers and the producers are sharing the code base between each other. And this can lead to circular imports, and that's not what you want to have in your app. Use Celery to its full potential. Read the docs. Always read the docs. They are large. They are quite nice evening reading. So when you have a boring evening, just open up Celery docs and read one certain topic on it. For example, deployment, or just about workers, or just about retrying. You know, it's really sometimes fun. I can recommend it. And always consider when designing your workers and repetitions, scalability of the third-party API that you are using, because you can be essentially DDoSing the other guys, and they won't be happy. That's it from me. I hope you like it, and I believe we have very little time.
We've got no time.
Okay, it's that simple. You can find me here for the next 3 or 4 days. I'll be here, so we can talk anytime. Thanks.
Thank you.